Heck, we're just going to jump in. All right. Welcome to Building Big, Lessons Learned from Windows Azure Customers. I'm Christian Martinez. This is Mark Sims. And we're from a team called the Customer Advisory Team, or CAT. We have a couple of functions. One is something like this, where we do public-facing stuff. We're part of the engineering team, actually. We're what they'll call the customer-facing part of engineering. One of our functions is to do content things and community things, and we call that the public side of things. Then there's the day job, which is we are tasked with being the team that drives early insights across STB, okay, into the actual customer deployments using all technologies and particularly challenging environments. Okay, that's our day job. That's what we do, kind of our 9 to 5 we're supposed to do all the time. Then there's a part that's not advertised, but occurs. We are kind of last resort, final airdrop into fires. So everything we're going to tell you and the people involved in that group are people who actively get dropped into real situations and have to do technical solving problems under extreme pressure, because otherwise it wouldn't have got to us. Okay? The way this talk is going to work is I'm going to open up with a series of kind of stories. And all the stories I'm going to tell you are real user stories. They really happened. I can't tell you any names, but I can show you they're from very large folks. Some are from us. It happened to us. And then immediately, we're going to dive off a cliff. It's just like a roller coaster. You're going to have me up here doing this. People like to say hand waving. I like to talk to my hands. First 10 minutes, it is going to be hand waving. I'm going to tell you a high level view. Then we're going to drop off a cliff, and it's going to get real nerdy real fast. So, how many of you have deployed something or are actively working on Azure deployments right now? Okay, so almost 80%. That's a good number. It's up. If you have never done any Azure work, this is an ambitious session. Okay. So I think we can do the flip to the story thing.
Yep.
So it's story time, Christian. Okay, I get the fun part of this. Mark will get really excited. You'll get nerds and windy bugs, so it's coming. But first, we'd like to set the stage. So let's first talk about abstraction. One of the patterns that we had somebody doing, it's a very large entity. I'm just going to say Company X so I don't get in trouble. Everybody I'm going to talk about is Company X. Company X can be anyone from a government to us, a company our size. It can be a startup that you've definitely heard about or a deployment you've definitely heard about. These customers I'm going to talk about are usually in the top 5 Azure monthly report, meaning they're the biggest billers to us, so we know about them. One thing, abstraction. So here was a pattern that was given out. We've had people, and this lesson here is abstraction. And so what they did is they handed out a storage account, and then they gave the customer was a container. So it seemed very efficient at first. And so they would do all their transfers and everything to that container. It's just resty. It looks really nice. And it worked at first. Right? Anybody want to interject quickly that with that direct pattern, some of the things that could happen? And if anybody knows about what happened around last June, they'll also know there was a change that also affects it. So this was a pre-June storage count. Does anybody have? What are just some of the easy things that can happen by removing abstraction? Not too many containers, and it wasn't even necessarily a capacity issue. We did a couple things. Well, it started to get to be. A, you have contention on a single storage count. B, by removing the abstraction, and you do things like you switch to Q10 storage and new flat storage, that's many times better. Those storage counts you have to move the storage count. You've allowed people to have a direct link to existing URL. You didn't abstract it and do it dynamically. You also can't move them without sending them an email saying that their container's been moved, et cetera, okay? So it looked great at first. It was super scale at first, right? I'm using storage directly. I don't have intervening hops. But that removing abstraction is now causing the whole country level, okay? So that's one thing, removing abstraction.
It's causing a word we can't use on stage.
Yeah. So another one. Let's talk about another one. We had a customer. This is a different story, but it's another large-scale story. So you go and deploy something, and they'd heard that you shouldn't block. Okay, and this is one of the number one customers in the space. And so what they did is they would do this operation, and then they would fire off a thread, and it was in a web role. And it worked great at scale. Not only that, unlike a lot of customers, they had lots of application telemetry. One of the biggest things that we run into, and Mark's going to talk about in depth, is lack of application telemetry. In their case, they had tons of application telemetry. Well, if you're doing things that are eventually going to cause thread or out-of-memory exception, you are not going to catch it in application-based telemetry. What happened is you disappear, and you have no reason except what happened. So we're going to talk about that. These are, again, real stories. We'll talk about there's a situation with connected cars. How many people have cars that can talk across the internet and get information and stuff like that? In this case, what they did is they not only had some concurrency issues, they also hit a hot spot in one of our popular frameworks where they were basically going against a non-concurrent collection. This is not obvious. This is not obvious kind of stuff. You're going to have to drop into the debug for this. The internal collection is not concurrent, not designed to have concurrently, and they're locking on hotspots. Okay? That's one that you can't just say, oh, I would never have done that. If you use that framework, if you told them to use that framework, you're going to hit something like that. Here's a fun one. This was actually one of ours. It was a service. You've all heard the service's name. They did the diagnostics. They did their telemetry. They did the telemetry, and they sent it to the same storage account that was also used in the path of the service. So if you have a super large scale thing, first of all, you need to use a lot of, more than one service account, but you definitely never want to send telemetry or logging to a path that's, a hot path. And then let me go with another one here. Oh, this one is a very famous one. I can't tell the whole. This is a great one. Very large deployment, very famous deployment. Exec presentation, and this is one I'll leave before Mark gets going. So imagine your exec. You do a presentation to execs. They come in. They come to see your site, and they go, ta-da, here it is, the biggest thing going that anybody's ever heard of, deployed on the edge, and it's floor four, it's not there. And the reason it's not there is inside your code, you had depended on a third-party service. So you did, hey, I'm using service-oriented architecture, I'm doing these great things, and this service performed a function that made sure that people that say dirty words like myself are not allowed to do that live in your environment. So they called this service to cleanse the words. Well, they did it in a synchronous call. Now, this is a site that gets 90,000 to 100,000 concurrent connections. So they basically told IIS, I'm going to use all your pull in a blocking manner, which caused them to stop sending requests on IIS, which after a while caused their CDN provider to stop accepting their requests, which completely shut out their website. And if you saw the code, a lot of people would say, that's good code, because it was nice, it was clean, and it didn't look dangerous at all. But the ramifications were horrible. So that's a lesson in asynchrony. So without further hand-waving big story things, I'm now going to move over and let a guy who wants to show you at a very deep level how some of these problems kind of manifest themselves in code. The other thing I want to drop in is we actually react well to heckling or hard questions, so if somebody wants to throw something out, feel free to throw it out. Thank you.
And if you guys don't throw stuff out, we will throw stuff at you. We'll start with questions, and we'll move on to water bottles and luggage later. It'll be Canadian. Okay. It's funny colors. It's very confusing. So Christian just finished off on a large website, or actually started with a large website doing asynchronous work. And they said, okay, we want to go with the simplest possible thing. We're going to put some code together, and it's going to be very straightforward. We get a request, we pull some stuff, we spawn a thread, we come back. I think we may even have sample code on MSDN that says to do this. I hope we don't, but we may. Everything was running fine. They did load testing, they did stress testing, they did all their tests, everything was great. And then they roll out into production, and the real load shows up. Real users doing real things that hadn't been thought of in load testing. And everything's running fine, until the most important day of the year for them, or like the run-up to the most important day. Then all of a sudden, the site starts dropping off. Instances just start disappearing. Telemetry says, we have no idea what happened. It's just not reporting anymore. Turns out that in very certain situations, there was one workload that generated a lot of long-running asynchronous activity that was blocking on something behind the scenes. There was no bounded concurrency. There was no limit, no resource constraint on a shared resource. And the site, basically, because every thread you can create as many as you want, but everyone's going to be a mega stack. So at some point, you run out of memory, and the whole process tips over. And Azure goes, hey, that system's unhealthy. I'm going to yank it out of rotation and reboot it. And then all the load that was coming in and resending these activities, because there were retries built in, was sending more load to the other boxes, causing a cascading failure. So what's wrong with this? There's a lot of stuff wrong with this, so we'll start off with an easy one. Let's just start from the really simple one. Should I ever, in the days of .NET 4.5 and above, ever manually create a thread? No, absolutely not. And what I didn't show is they were using thread aborts. Were you guys using thread aborts?
No, they just let it keep going.
Okay.
They didn't understand why everything would just stop.
I have had spirited technical discussions, and I'll let you guys interpret what that really means, with a number of customers in the last month when I'm looking going, thread.abort. Okay, if the very next thing is tear down the application because I'm done, I'm okay with that. But randomly corrupting my app domain because I don't want to use a cancellation token, this is terrifying. We're going to start with the basic stuff. You guys are like, come on, let's get to some big stuff.
No, they did the opposite. Even if I'm doing something wrong, you will not kill me.
Yep.
So I'm just going to live forever.
Because that memory, it's all mine, forever from now until the end of time. So we already talked about, well, if we've done that with tasks, that would have been interesting. More properly, if it was a long-running activity that didn't need to touch anything else, if it was meant to be an interactive activity, this should just be an async web API control end-to-end. And I'll show a little bit of code on how easy it is to do that later. Folks using async and await? You guys are cool. Good stuff. We've actually, if you'd asked me a year and a half ago, would I do a lot of async code? I'd be like, no. This stuff's too crazy. You're never going to get it right. With tasks and async await?
I was just going to say, quick question. The folks using it or not using it, is it because you already have too much stuff written that isn't using it, or it's because it's new and you haven't got around to it? Let's go with the show of hands. New and haven't got around to it. Okay, let's go with the show of hands. I got too much stuff baked in the old APM style. Okay. It's actually a good story.
There's the real thing. Why wouldn't I just throw it off to a queue? That's absolutely. And we'll get into where you get in trouble when you do that in a little bit. But yes, absolutely. If it's interactive work, if I'm basically going to sit there waiting and it's an I/O-bound activity, yes, I'm going to want to go full async end-to-end. I want to bounce it back. If it's not interactive, if it's not latency sensitive, if I can queue it up and deal with it later, take that message, jam it into a queue, and again, your queuing technology of your choice, and then return and have some handle that lets you say, hey, this is done, this is not done. You would absolutely want to use a queue for most of this stuff, because then you're doing your rate leveling. A huge pile of work comes in, the queue absorbs it. And you're never going to spend, you can control how many processing threads or how much processing work you do. But you can get in trouble there too, which sets us up for the next story, for someone who said, hey, we've got a bunch of connected devices. I think they started with about 100,000, targeting a growth of about 200,000 to 300,000 devices a month. So not a bad size. So periodically, these devices would say, hey, I've got some new information, I want something to be done, I have a question. Gets shoveled up to a web service, gathers the data, does the validation, puts it in a queue. It happened to be Service Bus because they needed some pub/sub capability, and came down to the workers. So they had two really interesting problems. They needed to maintain a lot of throughput. They needed at least 5,000 messages a second. But they also, because of the retry logic on the device, could never take longer than 8 seconds to process a message. And 3/4 of that's just cellular network time. So we've got to be half efficient. So let's just walk through a couple generations of what happened, starting from the stuff we tell you to do in the samples. All right, so throughput's important, so I'm going to batch. Seems reasonable. Chunky is usually better than chatty. Good start. The actual code was asynchronous, but I didn't want to show you guys the 17-point state function for doing asynchronous receive in Service Bus because it's ugly. It works, but it doesn't go on a slide very well. So just assume this is actually properly, the receiver code is properly asynchronous. And then I process a message, and then I flag a message. What's hideously wrong with this from a latency perspective? I'm going to give you a box of messages.
He's got a hand.
Oh, a hand?
Oh.
Sorry, the lights are bright. I can't always see hands. So the callback's one, but I'm also doing messages one by one by one. So I'm never going to process the last message until all the messages before it have completed. So if one of those takes 3 seconds, any messages after it can never take less than 3 seconds. And in this case, they were happening to take, when we first showed up and we're looking at this and going, 37 seconds to process the last message in the queue. I don't think you're in SLA anymore. We should probably look at this. So, okay, how do we go from sequential processing to fully parallel processing? So let's just flip it around. This is the starting point. Processing in sequence, too much latency. Okay, not very exciting. So let's change things up. Let's just spawn a new task. Let's drop something in the task pool every time. Task pool is bounded. It's not going to run out of resources. I'm on a worker thread, so I'm not using the task pool for anything else. Well, that doesn't seem like a bad place to start. Anything that seems like it could go horrifically wrong here? Oh, so what I didn't show is that process message. Actually, I didn't show you the full process message. Process message has a full try-catch around it. I just didn't put that in, but good one. Because if you have an exception in processing a single message should not bring down the entire processing host. If you use the, yes, so we should be basically looking at a process by process. We'll talk about poison message handling in a little bit. All right, so started off pretty good. We went full async. We went basically full parallel processing. We were cranking 5,000 to 6,000 messages a second for a very short amount of time. Then all of a sudden, the application goes to 100% CPU utilization on every single core on the box, and message processing goes to 0. Oh, and the execution time to have individual ones finished starts going into the minutes. This should be 200-300 milliseconds at most. Contention, deadlocks. We know it's a deadlock because it's a CPU burn, not a live lock, where we're basically doing a thread stall. So how would we look at debugging this? Any thoughts? Anyone used WinDBG on a production site? Really great experience, huh? I bring people with me for it. We'll show an easier tool in a second. So I happen to have a WinDBG expert with me on site. He's a little crazy, but he's very helpful to have around. No.
Debugger.
Yeah. All right.
I don't need the debugger.
Yeah, Christian does not WinDBG. He is a psychic debugger. He just looks at it and goes, I think something's wrong.
I'm so old and been through so much, I kind of just smell it.
It's actually kind of creepy to watch. All right. So we look in WinDBG. We utter the magical incantation that says, yeah, all threads are blocked. Everything's basically bound up in GC. Oh, by the way, at the current point in time, worker roles run in workstation GC mode by default, which means you have one mark and sweep collection thread. And if somebody's blocking that, everyone's blocked. All right, so who's the culprit? Oh, dictionary.findEntry. That seems interesting. So essentially what was happening is this is a message-based dispatching system. So you almost always have a function table that says, message of this type, invoke this function to process it. When I was processing a few hundred a second, no big deal. I was never getting up to that inflection point where I start just hammering that dictionary. I start to do 5,000 a second. all starting almost at exactly the same time, because I just did task new. I didn't put any jitter in there. I wrote this, by the way. We were working towards a solution. All of a sudden, find entry has just crushed the system. So this was an easy fix, even if it did happen at 2 o'clock in the morning. Any suggestions? Concurrent dictionary, the one-line fix. 3 hours to find it, 13 seconds to fix it. We'll be coming back to that theme a lot. We'll have some that are easy to fix once you find them, and some you're going, well, we made some bad decisions about 6 months ago. Okay, most threads were blocked in find entry, and we're just using a dictionary to the bulk of the message handlers. Anytime you're doing one of these function dispatch tables, it's almost always in a concurrent mode. So I just basically drop in, make sure we're using an iDictionary interface, implemented with concurrent dictionary.
No, so there's a lot of work that those guys did. They know the CAS instructions. They know the blocking primitives. They did a lot of work to make it so that, it wouldn't be just you doing the equivalent of lock. Okay, so, yeah, they're concurrent. They're highly concurrent, which is why they're called a concurrent collector, right? They understand parallelism and concurrency at the same time. No.
They're pretty sophisticated.
Yeah. Some of those guys are writing an operating system okay, so yeah.
It's a function table. It's basically, I have a message type, and I need the corresponding function. It's a lookup. You're absolutely right. There's other areas where we're passing the data. Queues, absolutely. This was a lookup. But concurrent queue, my second favorite concurrent collection. The blocking collection, which wraps around it, it's actually my favorite. Is anyone using blocking collection?
You have a question? Go.
Yeah. So is that function lookup baked into Azure? Or is that something?
No, the application code. Pure application code.
Why isn't it baked into Azure, given that would be a pretty, that's what's enabling the pub sub?
No, this is the message processing.
So you use a messaging engine generically. You don't want to tie in to what you're going to dispatch off of, so you use some kind of O1 lookup.
Yeah, but I thought you were saying that the message type basically corresponds.
Oh, a message payload field, that's all. The application message type, not the service bus message type. It's just a payload thing. Consider this similar to the routing table in MVC or Web API. You're just going to use a promoted or an inherent field to route to an execution function. So this one was painful to find, but relatively straightforward to fix. But we fixed it. Still not right. Something weird was going on. So we weren't stalling out with CPU. We weren't basically space heatering the machine. But after a while, we start to see this huge swing between min, average, and max latency. And CPU drops to nothing, and we get like 5 messages a second. And these queues just building up. OK, sounds like another contention. This is a thread stall contention. I would ask if you'd guess, but I never would have guessed this one, so I'll kind of walk you through. Has anyone used perf view from Vance Morrison? Few nods.
No,
Okay.
over here.
Yeah.
Over here.
So perf view, while Vance is a brilliant guy, he should never write a user interface. However, it's still kinder than WinDBG. So basically what perfview does is it sets up an ETW collection that can basically get all the stack transition events. It's basically sampling data. It's not hooking into your application. It's not debugging your application. It's just observing the stream of telemetry that's available in Windows. And in a cloud environment, this is nice because I can set up a job to run this on the server, stage it off into blob storage, and let me noodle on the data locally. Especially since in a world where I have 100% CPU, I can't really run WinDBG very well. So as it turned out, what was going on was most of the threads were stalling on system core, so basically MS core lib, system dynamic utils, type extensions, get parameter cached. The emphasis was very deliberate. So when we hear a cache, what do we think? Static, shared, contended. It seems like there's proper thread yielding going on because our CPU is at 0, but we're not doing any work. So armed with our trusty reflector, let's actually go in and look at what's going on. So I'm going to take an app domain wide lock and look inside a dictionary and return a value. Any guesses who? There is a .NET, a very common .NET framework used for data access that calls this. It's not Link. It uses Link, but it's not Link to SQL. Entity Framework. So an Entity Framework creates a DB context. For every single DB type in that class, it has to go and get the expression method to avoid using reflection to get properties. So it's a performance enhancement. It's a legitimate one. Otherwise, you'd get killed every time you wanted to go between an entity type and a native C# object. The challenge comes when you do this with a concurrency of 5,000 messages per second, and your entity framework data model has 34 data types in it. So when you hit this lock 150,000 times a second, bad things happen. The interesting part was 95% of the messages were doing an insert or a single row select. They weren't actually using Entity Framework to do anything, to actually play to its sweet spot. So what we actually ended up doing in this case is using telemetry, using measurement, identifying the top 5 messages that were hit the most often, which also had the simplest data access, and just doing a direct ADO.NET connection. The problem was, again, coming back to the layers of abstraction, they went from message process directly to an Entity Framework data model. And Entity Framework has a way to bypass, it can just run ADO.NET commands directly. The problem was generating the data context. They took a bet on a system interface, a concrete interface, not an abstract one. Otherwise, we could have just put a little bit of pointer in there. This ended up taking a couple of days for them in order to be able to go in and rewrite and basically bypass some of that stuff. So that was actually a pretty nasty change. Okay, so this always gets me in trouble. The last time I said this, the Entity Framework team called me, the .NET team called me. Most technology has a sweet spot where it's basically saying, I value one thing over another. There's always an engineering trade-off. And Christian's laughing because he has a firmer opinion on this than I do. I'm being nice. ORMs are great for agility. They are. That's what they're designed for. But if you go with agility, if you go with more abstraction layers, you give up performance. So I'm not saying don't use them. I'm saying that there are instances where it's okay to use multiple pieces of technology optimized for different use cases. Trying to have one true thing to do everything in a large dynamic system with a lot of different workloads usually means you're optimizing for nothing and picking up pain at the expense of consistency. Now, there's one end of that spectrum, and there's another end, which is I like data access layers so much, I'm going to use all of them. No kidding. We had at least 2 customers this year that love data access. So they're using Entity Framework and Link to SQL and ADO.NET and the Patterns and Practices data access class. Have I missed any? They didn't have NHibernate.
If I could just have one soapbox moment. We've had a fundamental shift, and Herb Sutter's written a lot of stuff on this in his advocacy of native stuff, but it applies to pretty much everything, where we love abstraction. We told you have to abstract, but there's a difference between abstraction and then looking for the total easy way out in a cloud world. In the old days, dev time was the king of every decision, okay? And the faster you dev time at the market, it was fine because everything was sunk cost and basically you paid for the. Then there's a famous quote that everybody repeats from the premature optimization is the root of all evil. I say that's probably the worst quote for today that you can ever listen to. If you don't think up front in a cloud world about the implications of any clicky, draggy, drop, anything that's made easy for small things, down the line. Now, is it our job eventually to make it so that really big and really can scale? Yes. But in the meantime, until we become perfect,
we've been kicking at that one for a while.
If you don't think about things first, it's going to cost you lots of money. That's all I'm going to say. So, otherwise, if I keep going down a certain path and name names, it's going to cause a big stink. But yeah.
The key thing is, I usually like to refer to it as just making a down payment on being successful. Do you need to hand code everything up front? No, it's probably just a waste of time.
You had a question?
Yep. Do you need to make sure that you have a layer of abstraction or a layer of indirection, really, such that you can make changes as you get bigger and your workload changes? Absolutely.
You had a question, Mark?
Yeah. Could you use a microphone next to you, please? Sorry about that. It's a big room in the acoustics, sir.
It seems that the issues you're talking about are related to scaling. So when we scale to, way beyond what it was tested for, all kinds of problems happen. Is there a good way to just test this in-house before we get to the problems?
At a certain scale, the only testing that's practical and has a high degree of fidelity is testing in production. Sorry, guys. So, but let's, again, there are nuances. Let's tease that one apart.
It sounds funny, but if you're doing, say, Skype, you're going to build something to test Skype? All of Skype?
Yep, it's called Skype.
Yes.
So, but let's actually tease that apart because testing before you go into prod still has value. So a couple things you can do. You can deliberately dial down the amount of resources allocated to your test cluster and test its breaking strain. In fact, if your load tests are not physically destroying your test environment, you have too many resources allocated. You want to know where it breaks because that'll give you a hint. Do we handle these breaking points gracefully, or do we just kind of fall down and spit back bad error messages to the user? You can also, and again, we're talking about big stuff. You're going to have a lot of engineering investment. You're going to take iterations to get there. We know you're not going to start there on day one, but we want to talk about some big stuff.
Which was the title of it, right?
Yeah.
We did say building big. We did
I
warn,
hope we weren't too
We
subtle
did
about
warn that if you have small things, none of this applies. But
So one of the things that we have a lot of customers doing is A/B testings, partial rollouts. I'm going to take one upgrade domain, and I'm going to push the new version of the code to that upgrade domain, and I'm going to measure it. I'm going to wait. I'm going to see what happens. And then I'll do a little bit more and a little bit more. It requires a lot of investment in your ALM capabilities. It requires a lot of operational rigor. Cowboy deployments, probably not a good idea. But there are capabilities in the Azure platform to make this reasonably straightforward with the right investments. But yeah, we're not saying don't test. We're just saying that don't expect your tests to have full fidelity because users do crazy stuff. Yeah.
With this situation, was it mostly inserts or was there updates?
95% of the query of the message processing was inserts and updates. Single record inserts and updates. So stored procedure with native ADO.NET or Dapper, just streamlining that all together. Yeah. And most systems tend to have that Pareto curve where like 20% of the time occupies 80% of the work. So the question was, would I still hit the same bug if Entity Framework was using stored procedures? Yes, because it wasn't Entity Framework's execution code. It was Entity Framework's type cache. The bug's actually in the .NET framework. It's not actually an Entity Framework. They were just saying, hey, .NET, I want you to give me a cheap and easy way of extracting properties from this known type.
and you actually asked the question. You saw the lock, right? You said, did they just take the current and put the lock in there, right? Obviously, there's other ways to do concurrency. They need to look at it.
We actually have another customer who hit the same issue. They grabbed the Entity Framework source code and overrode the internal class in the .NET Framework, and they were off to the races. Oh, that was just highlighting the whole thing that WinDBG said. Basically, what that meant was that the GC thread had been stalled. Again, I need an interpreter for WinDBG. It's like the UN. I go there and I'm like, WinDBG is telling me things. Hey, Chris, what does this mean? Okay, so once you get into this kind of scale, message-driven and queuing systems are going to be the order of the day. You're going to have a bunch of interactive work, and you're going to have a bunch of background work. And we have all these pretty samples up on MSDN that say, here's how you use the queuing APIs, and here's how you use the service bus APIs. And unfortunately, we've had customers that thought that the getting started guidance was the getting big guidance. It's not. Here's just some of the things we've talked about, and you've seen how it jumps out. So if I were to say, when would I use service bus and when would I use queues, could someone give me like a one-phrase answer? I'll give you one. This is when I'll have two more teams mad at me. Actually, we have an answer from the front, but he's a Microsoft employee, so it doesn't count. It's real simple. Always use the simplest possible thing that'll work, but no simpler. If all I need is cooperating producer, competing consumer, you're not going to beat an Azure queue. It has no moving parts. It's baseline storage. If that's offline, you're hosed anyway. So, and it's very reliable, and it's very predictable. It's in a single tenant service. But if I need pub sub, if I need multiple consumers getting a copy of the same message, then Service Bus or other message brokers become a more reasonable choice. We have a 13-page paper that basically says that.
What if I need pub sub, but I don't need durability, I want low latency?
I would use Apache Kafka
Okay.
on Linux. Runs great in Azure. .NET client's a bit iffy. We're fixing that. Well, we're fixing that. That's not an official statement. All right. Partitioning and load balancing. How many messages a second can I get through a modern a storage queue that I went and created today? Sorry, guys, I'm a little deaf up here. 2,000, actually. It's 5,000 ops, but I have to insert, get, and then delete. So count around 2,000. So if I need 5,000 messages a second, I should probably have at least 3 queues. Once I have 3 queues, I need a partitioning mechanism and an affinity mechanism so that I don't have all the producers going into one queue and all these lonely, heartbroken consumers sitting on an empty queue. It's probably not very good. But so I have to think about these partitioning things. Latency and throughput. If I batch, I get more throughput, but I may take a latency hit. Message dispatch. Once I get a message, what do I do with it? Poison messages. This is a fun one. You will not find poison message handling in any of our Azure Queue samples. But if someone sends bad mojo, and they will, and your message processing system just has no idea what to do with it, unless it's checking the DQ count of the message and eventually flushing it out going, I have no idea what to do with this, it will eventually dominate the system. And you'll basically be sitting down, spending a bunch of money. We're okay with that, but CSAT experience, processing messages that can never be processed. So that's our internal code word for you call us and you're angry. We like to avoid that. We want you all to be happy. All right. All right. This is a fun one. Every piece of the platform has a limit by design. Azure is absolutely a scale-out platform. I can give you 1 million gallons of water in 1 liter bottles. I cannot give you a 1 million, a million liter water tank. This is called, we're going to work with the platform. We're going to go with basically composing more smaller units. So a large website, 100,000 concurrent operations a second, 500 SQL Azure. I can't say that anymore, can I? Azure SQL databases.
Windows Azure.
Windows Azure SQL databases. So if I just call it SQL Azure, you guys won't tell on me, right? Okay. So application, huge numbers of users. Traditional 3-tier app, web tier, app tier, database tier. Why are the web and the app tiers physically separated? Why am I paying the cost of basically taking data, turning it into a byte array, shuttling it across the network, and bringing it back?
Because for years we've told everybody that's how you build large-scale applications.
In a cloud service with a security container, the eggshell is the cloud service. Do I get anything out of an interactive direct connection between a web and an app tier? Unless I start doing some crazy deep packet inspection on the app tier, and I can do that just as easily on the web tier and save myself an expensive network hop. Customers getting killed on latency going from their web rendering through WCF down to the database. So they basically took the services, jammed them together, and I think 300% improvement on latency. Created a slightly more interesting challenge. So in this world, what can happen if I'm extremely successful? You already know the answer. The answer is going to be it blows up. The question is, what's the inherent limit for the communication between a cloud service and another cloud service? Because SQL Azure is a cloud service.
Make it easier between any...
Network? Network ports.
Yes.
Ah!
What's the number?
You guys have been reading ahead.
Close enough.
Fantastic. I wish I had a prize. I would give you a prize. First time that question's ever been answered. I'll go through this very quickly. Every cloud service has a single public IP, size of an IPv4 routing table with a fixed destination port, 65,000. It's actually a little bit less than that because of some reserved ports.
If you're looking for anybody to blame on that slide, you can pick the middle one.
Yeah.
Just kidding. If you...
120 web role instances, 500 databases, 100 connections per. You do that math, that number's a lot bigger than 65,000. And in this specific case, the load balancer version at the time went, too many connections. I have to preserve system health, as it was supposed to do. I'm killing the newest and the oldest connections. What does a very large number of partially open connections from a single source IP look like? A denial of service attack. So after your database cluster decides that your web host is a denial of service attack, you're probably not going to have a very good day. Unbounded concurrency, not affinitizing resources. We have ways of solving this, but at the time it was like, this hurts a lot. This was 4 days before launch. Because we believe in, just in time. Actually, no, we hate it. It just tends to happen a lot. Okay. All right. So this is one from the same one. Again, very large website. Christian alluded to this earlier. 0.5% of the time, I need to call out to a third-party moderation service. It's not something I do all the time. It's not a core capability, and it's important. So not only do I want to shift technical risk, I want to shift liability to that third-party service, because if somebody says something horribly nasty, well, that's those guys, not me. Again, you let the lawyers fight it out, but it's a pretty common thing where I take things that are not completely critical to my core workload, and I would never write something to send mail in this day and age. I'm just not going to do it. It's too many moving parts. I just want to connect to a SendGrid endpoint and shovel stuff at them. Why would I ever build that myself unless I was trying to be another SendGrid? So 0.5% of all service calls stalled out. Anything happened to the website? It's a rounding error, right? Very small number. You guys already know how this story ends. I've already set it up. Christian set it up. It blew up. So I don't know about you guys, but I won't wait 3 seconds for a web page to render, let alone 4.5 minutes. IIS is a bounded concurrency dispatch queue. I get 12 dispatch threads for every core in the box.
By default.
By default. You can change this.
You can run app command and do all kinds of crazy stuff, but no one ever does that.
So they hadn't changed the defaults because they're fine. Has anyone been to the grocery store and had someone in front of them paying with pennies or a check or any of that old-fashioned stuff? A few laughs. You've been at the airport and the person does not know how to use the machine? Okay, now we're getting to fixed number of slots, and basically the system moves at the speed of the slowest, and you get enough slow actors and the whole thing fills up. In this case, this is exactly what happened. A rounding error number of calls were basically blocking out. They were being called synchronously. They weren't being bounded. They weren't being killed after a certain period of time, and load was not being shed. So after a while, the system just tipped over. Just done. And until basically everyone went away and to tweet about how bad their experience was, which is exactly what they did, this was a 3-hour outage caused by a perfectly innocuous piece of code. Because to make things even more fun, the client proxy provided by the service, like the service provider gave the customer, here's the code used to connect to our service, it wasn't honoring its timeout values properly. That's why they trusted it. Trust but verify and have a cutout. Anytime you leave the process boundary, you can't trust that stuff. Bad and interesting things will happen. They might not. You hope they don't. But you at least want to have some piece of code that says, oh, I'm just going to stop waiting for that and at least just return an error and return those resources to the pool. All right, let's take a fun one. So who's got logging in their applications? If you don't, I invite you to leave now. Who runs with the same logging configuration? Oh, someone up and left. I hope there's just a bio break. Otherwise, if he comes back, don't let him in.
Well, when you gave him permission to test in production, he figured it was over.
I hope he's not out in the hall crying. Okay, so who has the same logging configuration in test and prod? Why not? Don't you want to be able to diagnose issues in production? How do you do that without data?
No, in the cloud, you RDP in and you go into one of the 3,000 instances and you figure it out.
Absolutely. The trick is figuring out which one of the 3,000. So I'm not going to, I have a whole rant. I actually would need a soapbox for this one, talking about how to build telemetry systems for production. If you have the wrong technology and the wrong approach, and I'll be honest, most stuff out there, including stuff in the .NET framework, does this very badly. If you turn on fairly rich logging, you drop the system. And in this particular case, who's using Log4net? Pretty good experience overall? So here's what happens to Log4net under heavy load. This is a Log4net stack trace. So the customer in question had a 2,000 millisecond SLA on a particular class of calls. If they deviated from any call, or like more than like 0.5% of all calls to this service, if it went over 2,000 milliseconds, they were out of SLA, they had financial penalties, and those awkward boardroom meetings, it was going to be all kinds of unpleasant. So I don't know if you can see it. Actually, I know you can't. This is an eye chart. Right down there at the bottom, there is a call, and this is from anyone using App Dynamics? Something to look at App Dynamics in New Relic. They give you a lot of this insight for free without having to bake it into your app. But App Dynamics is basically calling out, hey, the reason that this particular function call took 2.5 seconds, aka out of SLA, is because you stalled on Microsoft Win32, Win32 native, set file pointer Win32. So if I give you the hint that log4net was logging to the local file system, what happened? Nope, didn't run out of space. Sorry, what was that? No, it wasn't well, actually, yes, it was a file handle. Contention on the tail pointer for the file. Multiple processes, multiple threads were actually trying to open up and connect inbound, and they were blocking on acquiring that file pointer. So, writing to a local resource, everything was fine until it wasn't. This only hit 15 or 20 calls through the system in a day. It cost the customer a lot of money because logging brought them down. So what did they do wrong? Log4net is a reasonably good piece of technology, but it doesn't have an easy way to do purely asynchronous logging. It just doesn't. What we fixed it with in this case was we actually went out, found an open source component that had implemented an asynchronous file logger and dropped it in. Worked pretty well. A Band-Aid, but it did resolve the issue. Anyone using nlog? I'm a fan. Does quite nicely. Nlog has the ability to basically put async wrappers around everything, but it doesn't implement queuing. So if you basically get too many blocking async tasks, it just starts stacking those up as well. Does anyone go to Julian's talk on Tuesday about the semantic logging application block? Okay, for those of you who didn't, I recommend going back and looking at the recording. So ETW, right? Doesn't that thing just the most awful, painful tooling experience in the history of the universe? Anybody who's laughing has used it. We recently released something in .NET called Event Source, which says, forget all that manifest, forget all those XML files, forget all that registration. You just tell us what your structured logging looks like, and we'll do all the work. We'll create the manifests, we'll load them in memory, we'll spread them around. And with the semantic logging block, I get an easy way to read that data, put it in log files, put it in table storage. The advantage of using ETW, it's automatically asynchronous. It's writing to kernel ring buffers, so if they fill up, it'll just drop data rather than dropping your application. And you get a nice end-to-end experience. And you can do some in-memory auditing and in-memory coalescence as well. So highly recommend checking that out. I have a whole blurb on telemetry. I'm not going to go into it too much because we have too many other fun stories to tell. But kind of just leave you with, if you do not have the same level of logging in production as in test, you're handicapping your ops folks when it comes to find issues in production. I think he's going to go off and go do some test and prod right there.
You have a question?
So Windows Azure Diagnostics, was that?
Which logging?
It's a nuanced discussion. I have done it, but to talk about how to do it correctly at scale, we don't have quite the time. But if folks want to hang around for 5 or 10 minutes afterwards, I can actually show you how you can do that at scale. All right. So this is the one that Christian was talking about earlier, with basically clients having hard-coded into their applications or configured into their applications, which is just as bad. Basically the blob URI and the Q URI using the shared access tokens. So basically you'd go out. Do I have a laser pointer? Oh, look, I have a laser pointer. This is dangerous. So you'd go out, you'd go to your web role, and you'd say, hey, give me the keys to the door for an hour. That's what shared access tokens do, or shared access signatures do. So then the client, having its configuration for the blob API, is going to go out and hit blob and queues directly. Looks like a good design. Hey, if you went and read our documentation, you might do this. You would probably do this. In fact, they did do this because we looked at the code and went, hey, that's from the sample. That's pretty much what they did. Storage account URIs were hard-coded into the application, and when you have 100,000 clients deployed, This is not an easy fix. So what could they have done differently? So going with the direct writes to blob storage, that was a good thing. That's okay to have that direct dependency. It did create tight coupling between the client and the service, but that wasn't going to change a whole lot, so that wasn't the end of the world. We have a service that returns the shared access token. What else should it have returned? The blob URI. They hard-coded the blob URI but sent the key. So it's great if you already knew the address. It's like going to the rental car lot and you get a key with no clicky thing and being said, yeah, one of these cars out there, it will open. But if we've moved the car, you're in trouble. So bit of a nasty one there.
I just want to make one interjection. When we talk about adding this abstraction, we're saying these abstractions are very important. We're not talking about heavyweight abstractions. So I don't get a discussion about what your favorite, library or giant framework of the week is. That's not really the thing. It's at least have a thin layer at each one of your levels, especially when you're going to be accessing external resources, which all of these are. Have at least a thin layer. This. It doesn't matter. We're not talking advanced OO. This, so you can make a different decision later. Because otherwise you get in some really hairy situations.
All right. So that was all the kind of the deep dives in the CAN stuff. So we got a couple options here. Because this is partially a design your own adventure. Either that or we got boring. I'm not sure which. So we can actually go through and I can dive into some of the areas we've talked about around scale, around logging, around kind of the layers of abstraction. Or I can open up a customer problem that we're working on right now and you guys can help us design it. Customer problem? Okay, customer problem it is. Good, that's the slides I have. Okay, so we said we're going to talk about connected devices. This is whether it's mobile apps, whether it's cars, whether it's industrial electronics, we're connecting a lot of stuff to the internet. The old kind of hypey term for this was the Internet of Things. That's starting to become real. We're starting to find reasons to actually connect things to the internet and deal with the data. But all of a sudden, I'm dealing with hundreds of thousands and millions of devices connecting into my services. I'm dealing with gobs of data. And I'm dealing with some pretty aggressive connectivity, throughput, and latency challenges. So let's walk through a typical kind of data design because for how you would basically store the data. So let's kind of go over what we're going through. I got 100,000 devices day one. They're out there. They're just waiting to get turned on. I'm going to add 50,000 a month, so I need elastic capacity. Starting off, I only have to worry about North America. I might have to worry about Europe and APAC later. And so I got 4 workloads I need to worry about. So every 30 seconds, the device is going to send me some data that I need to do an insert on. That happens pretty quickly. I need a certain amount of latency, but I only have to talk to a single device.
So why don't you, at each step, okay, so at that step, what's the first thing, or what things do you think about immediately from that first step? What comes to your mind? Okay, what kind of queue? Which one? Okay, service bus. Let's say I hit the 100,000. What do I got to do? Right?
So partitionality, that's a big one.
Right? If you do the partition, can you guarantee that 2,000 millisecond latency with a durable queue?
Ah, he was paying attention. Well, he didn't say that we couldn't lose data. Nowhere here did I say I couldn't lose stuff. Maybe I can lose 1 in every 1,000 messages. Maybe I can lose a certain class of messages. Different data in the system is going to have different value. It's not everything is transactional durable. It's device data. It's noise. We're throwing half of it away anyway. But literally, we are. I mean, every Windows server you have deployed, there are millions of events a second. You just don't have turned on, and you're not collecting them. But they're there. It's just background ambient data. I'm just not choosing to collect it. Not all of it has value, especially if it's a continuous data signal, like what's the temperature? And if I miss one, I can probably interpolate. All right, so this one, if we think about kind of the partitionality, affects a single device. So every 10 minutes, I need a batch job which gives me all of the data from the last 10 minutes. So it's basically a batch pull for a reporting job. We'll just talk about those two because we actually want to dive into design. We won't worry about the other 2 items. But we want to optimize for the hardest case first, the one that's the most latency sensitive. Because if every 10 minutes I need a batch job, if that finishes a minute later or 2 minutes later, the customer's not really worried. But I'd better get that data into the system in the latency, within the latency boundary. So I'll optimize for that one. Simplicity is king. Complex systems have complex failure modes, which means that you're going to be scratching your head going, it don't work, and I don't know why. We'll be back in that WinDBG, perfew, heinous thing. And I'm going to come back to there's no one true solution. If I'm developing a system from the transistors up, I gotta manage a lot of things. I may only want to have one highly available, resilient data store because it costs me a lot to manage the thing. Does anyone like SANs? Does anyone have a deep, abiding love for the storage area network? Good, I don't have to throw anybody out. We've gotten in this mode for very, very good reasons, where if I need highly resilient, don't want to lose data, I want to concentrate everything into a very small number of fairly homogeneous systems because they're just too hard to manage. I go into the cloud where different types of data are just API endpoints. It's okay to go polyglot. It's okay to bring in more service types and more service composition. So you might think, well, that sounds like a database problem, right? Christian, does this sound like a database problem? That's the I'm on stage face. So let's just think about this in a database world for a little bit, because this is where the customer we were talking with started. So you can't do this with a single database in Azure, because we're just not going to give you one machine that's that big. And since you're growing 50% every month, at some point you actually have to scale out. So it's an insert-heavy workload, which means that you are abusing the database transaction log. You are hammering that transaction log, because all you're doing is inserts. Partitioning keys. Device and user account seem natural because I'm mostly doing inserts on a single device. But if I'm doing inserts on a single device, then I need to be able to span the last 10 minutes. That's a lot of point-wise lookups. I have to hit a lot of partitions.
Just a quick question while we're in this space. How many people right now are dealing with or have written heavily sharded solutions? When I say heavy, I'm going to say you have 200 to 500 databases out there right now. Oh, it's you. Okay, yeah, okay. No, it's not. Well, no, it's not.
It's not.
But if you don't, and this is also one of the things, if you don't think sharding first, and you're going to use Windows, Azure, SQL database, and if you don't think sharding up front, you're almost guaranteed likely to be making a mistake because
you are going to have a bucket of pain, a big bucket of pain. Well, actually, really, the question is, would I even use SQL? Let's start there.
I didn't say that.
They do, actually. I didn't, there was a couple down there below. I said we'd skip for now, but users do need to go back and do individual lookups on their device data. I left that one out. Throw that one in there to see if you're paying attention. All right. Periodic query spikes. If I come in, do a bulk extract, what's that going to do to my inserts? Nothing pretty. Rebalancing is pain. Noisy neighbors, if you're using Azure SQL Database, you can get throttled out by somebody else. If I'm rolling out on SQL VMs, I'm probably going to need a lot of them, and all of a sudden I'm managing a lot of servers. And, I don't really have I don't see any relational data here. You guys see any relational data? Maybe that batch export, but that doesn't even, I'm not working off of keys. I'm just saying, give me stuff in a 10-minute window. No, I had to export. I didn't have reporting. Reporting's someone else's problem. All right. So,
push back. Don't let them get away with that.
We expect you guys to handle.
It's great to say use this heavily partitioned magical store that just keeps growing with your partition key.
Yeah.
Now answer the other question. I want to figure out what happens someday later over a range of values. Make him answer it.
Yeah, actually, I will. In this case, it's entirely legitimate that there's an upstream system that's extracting data via bulk load, and it's responsible for building all the analytics and reporting. And it happens to be running in an on-premise data warehouse. Okay, Insight Challenge, we'll skip over that. Instrumenting, we'll skip over that. Oh, dump. So, here's how we solved it. I just skip ahead to the answer because we only got a few minutes left. I'm going to do some questions at the end. It's not a relational workload, and it's okay to do two different things. So in this case, what we said was, for your lookup data, your per-device data, put it in tables. Anyone want to guess what the maximum number of partitions I can have in a table store happens to be? So what he's saying is it's big. It's massive. I don't even know there's a word for it. We have applications in productions with billions of partitions in table storage. You're going to hit the operation cap on a storage account long before you're going to hit the partition limit. So having a device per partition would be insane in a relational world where a partition is a big, meaty thing. Table storage, yeah, it's fine. You can basically just make each one of the row keys the data type or the collection of schema. So there you've got your single inserts and your single retrieves. You're not contending on resources. But if I have 1 million devices and I have my data just in table storage, and I need to get my bulk data out every 10 minutes, I have to make 1 million calls to each of the partitions. That's not going to work very well. If we were thinking about doing this with just a single solution, we'd have to optimize for neither. But instead we went, why don't we just jam all the data in blob storage, and when someone wants to do a bulk export, just grab the blobs. Seemed pretty simple. And that's what we did. Compositional approach. We had 2 main workloads. We optimized for both of them with independent systems. Do we have consistency between those? Nope, not at all. Did we need it? Not really. There was nothing in there. There was nothing in that workload that said we had to be consistent about the device telemetry data outside of the specific device. And since the reporting data was going to be a little bit out of sync anyway, because there's just a natural ETL process associated with it, it was okay if it fell behind a little bit. So we're coming up on about 2 minutes. Any closing thoughts there, Mr. Martinez, while I flick ahead to the...
Yeah. Keep in mind that when we did talk about certain boundaries, certain things, again, the title was building big. So no, everything we talked about does not apply to every case. But then also remember what I talked about. If you ever want to be and you plan to be successful, if you don't think about it first, you'll be paying either lots of money to keep a suboptimal system going because you'll have to add twice as much, or you're just going to break. So you are the only one who's going to know what you're aiming for. So if you're aiming for small, some of what we talked about absolutely doesn't matter to you. But if you're aiming for big, you're aiming for success, I would keep all the things we talked about in mind. In the final minute, who's got great questions? This would be fun. Who's got any questions? No questions. Oh, there you go. Hey.
That you showed. Those queries, you mentioned that they were simple inserts and selects and what have you. Was it a case that they were frequently used queries in the application?
Absolutely. The 2 or 3 queries were being hit 90 to 95% of the time.
Okay, cool. Thanks.
Yep. I love ambush questions. Yeah.
What suggested model for Azure account developers access at a lower level of experiment features get locked used out at a higher level? Like in AWS, I have a different account.
Yeah, so we're frankly working on the richer operational aspects of the accounting.
So like in the current model,
I would give a subscription for dev, a subscription for prod.
Yep.
Keep it isolated, because that way a developer can't accidentally deploy today's hairy new code to production.
No, that's because it is definitely something we know, we've heard of, we've talked about, but right now you got the brute force answer.
Yeah. Oh yeah, and if you want to fill out those evaluation things, that's
Yes, sir.
cool. Oh, sorry. The question was, what's the impact of using the reactive extensions to do analytics over streaming data? Watch Julian's sessions from Tuesday. So for those who aren't familiar with RX, it's essentially a .NET library for dealing with push-based data. And we've had it cranking 15, 20 million events a second on a single node. Once you get across network, it gets interesting. But the event source stuff together with Slab lets you get a push-based stream of telemetry events and do in-memory analytics. And most of the applications we're talking about in the cloud are going to be I/O bound anyway. So you generally have a little bit of CPU and a little bit of memory to spare. We've got a number of internal systems, and we're starting to roll this out with customers, where you basically take the telemetry stream, dump a slow copy in a file, look at the live stream in memory, do live analytics, look for conditions, and then report aggregates upstream. And as long as you're not cranking more than 1 million events a second, we generally don't see any problems. So I would generally use the file. I always want a raw copy that I'm going to stage off into blob storage and probably hit with Hadoop or some other MapReduce bulk analytic later. The live analytics are for the things I want to know, the questions I always want to ask. The file is for the questions I might want to ask down the road.
And things can go to more than one place.
Yeah. So we're already over time, so I just put up the resources slide so the recording gets it. The extended versions of the smaller scale talks are on Channel 9 or on Failsafe, and we've got a bunch of reference code that encapsulates some of these patterns in CSF, in the Cloud Service Fundamentals that we're continually updating. That's basically our cookie jar for samples. And we'll hang around for a few minutes if folks want to ask questions while we're not hogging our friendly AV Tech time. All right, thanks, folks. Thanks for sticking around.